Okay, so we're going to go ahead and continue with our topic on compound interest. So we're going to go ahead and take a look at another example here. And here's our formula here. So it says determine the amount Fred will have in a savings account at the end of 10 years. So that's our time, 10. If he invests $2,000, so that's the principal, the amount Fred starts with, at 4.5%, so that's our rate. But remember, when we write our rate, it has to be as a decimal. Now our percent is a decimal, but we have to take away this percent symbol. So when we take it away, we move the decimal 2 to the left. So we're going to use 0.045 in place of R in our formula. It says compounded monthly. So that is our N. Monthly means it's going to be that percentage rate is going to be divided out into 12 increments, so monthly. Okay, so now we are ready to use our formula here. So Fred starts with $2,000. They're going to take that whole $2,000 and add a percentage rate of 4.5%. And it's going to be compounded monthly for 10 years. Okay, so now we're going to go ahead and use our order of operations. So we're going to start with the parentheses first. So inside the parentheses, the division goes first. So we're going to do 0.045 divided by 12. So 0.00375, and then add 1 to it. And then next is the exponent, so 12 times 10. So we're going to continue with the exponent. So we're going to take 1.00375, raise it to the 120 power, and we're not going to write down all those numbers. I'm going to put ... to remind myself that there were other numbers on the screen, and just to show my work for my instructor. They can see if I get the wrong answer where, let's say you went wrong. So then we're going to do times 2,000, and we would get 3,133. And then the directions said to round to the hundredth place. So that means we only want 2 decimals, 2 numbers after the decimal. So we have to go to the third number, and since this is 5 or higher, the directions say to round to the hundredth place. So instead of 98 cents, since this is 5 or higher, it's going to be 99 cents. Okay. So we would write our answer as the amount in Fred's saving account at the end of 10 years is about $3,133.99. Okay, so let's go ahead and try another one. So this type of equation is application for this chapter, because in this chapter we talked about exponentials, and so we have exponents in these problems here. But the next couple problems is going to use the skills we learned in 10.7 because we haven't really solved or how to isolate a variable. The variable that we've had to solve for these equations or formulas, it was already all by itself. Now let's take a look at what happens in the next problem here. So it says Kyle invests $10,000, so that's his principal, what he starts with, and a money market account that earns 4%, so that's our rate, but we have to change the percent. We have to get rid of the percent and move the decimal over 2, so it would be 0.04. Compounded semi-annually, so semi-annually means twice a year. How long? So it just asked how long. How long is time? So we don't know what t is in this problem. How long will it take his account to grow so the end amount in to be $20,000. So this time when we use our formula here, we know our A. So it's going to be 20,000. Starts with 10,000. So Kyle wants his money to double, go from 10 to 20. And we're going to take that whole amount. We're going to add 4% interest. It's going to be divided into semi-annual, so twice a year. And we don't know how long. So we're going to go ahead and simplify. Parentheses go first. So we're going to do 0.04 divided by 2. 0.02, and then we're going to add 1 to it. Bring everything down. Now, the exponent would go next, but we can't do the exponent because we don't know what t is. So we can't do this. Therefore, then we can't multiply because this would have to go first. So you can't multiply these two because exponents go first. So we're stuck here. So this is an example of what we're going to use, the skills you learned from 10.7, because in 10.7 you learned how to solve an equation where the unknown is the exponent. So if we want to solve for t, we want to get this t all by itself. The first thing we're going to do is we want to get rid of this 10,000 because it's being multiplied to this. So this is all one term right here. This is together. This would go all together. So if I want to get rid of this 10,000 to try to get the t by itself, we're going to go ahead and divide by 10,000. Whatever we do to one side, we can do to the other. And we would get 2 here. Okay, then we have a problem. We have an exponent stuck, or a variable stuck as an exponent. So we learned that if we log both sides, that the power rule for logarithms allows you to move the exponent to the front. So we learned this again in 10.7. So that is why I'm allowed to move the 2t to the front. So remember, our goal is to solve for t. So if I want t left here and I want everything else gone, well, this 2 is being multiplied to the t. So to get rid of it, I would need to divide, because 2 divided by 2 is 1. Well, not only that, this is being multiplied to the t. So I'm going to divide by both of these. So I'm going to divide both sides by 2 log 1.02. So this would be our exact answer, because the 2 would, everything's gone and we're left with just the t. So if the direction said to leave the answer in exact form, this would be the exact form. And since it said to round, we need to put this in our calculator. So follow along with me. To put this in your calculator, you're going to do log 2. So log 2, and then you're either going to click equals or divide. So you can click equal and then divide. So it's going to be divided by, and since there's 2 things, if you want to divide by both of them all together, you're going to need to use parentheses. So divided by 2 log 1.02. Okay, so now I'm putting a parenthesis to close that log, and then I need another parenthesis. So you did it correctly if you got 17.50139, etc., etc. So to round to the hundredths place, so 2 decimals. So it'd be about 17.50 years. So in 17.5 years, pretty much, it would take Kyle to double his money to 20,000. Okay. All right. So let's go ahead and take a look at another one here. So here's our formula. It says, suppose Sarah invests $30,000, so that's the principal, that's how much she starts with, and a money market account that earns 5.2%, so we get rid of the percent by moving the decimal over twice to the left, so it'd be 0.052. Weekly, compounded weekly, so that's how we know N is 52, because there's 52 weeks in a year. How long? So again, we have to find the time it will take Sarah's money to double. Well, if she starts with 30,000, if we want it to double, that would make 60,000 if you multiply 30,000 by 2. Okay, so this is similar to the last problem, so we're going to go ahead and plug everything into our formula. She wants to end with $60,000. She's starting with 30,000. Her interest rate is 0.052. It's going to be divided by 52 weeks, and we want to know how many years. So feel free to pause the video and try this on your own, and then you can push play to check it. But we're going to go ahead and start inside the parentheses. So 0.052 divided by 52. So that's 0.001, and then we're going to add 1 to it. And then we can't do exponents. We don't know what the t is. So we're stuck. So luckily we learned what we learned in the section before this, how to solve equations with exponentials. So we're going to go ahead and get rid of the 30,000. Remember, you can't multiply these because exponents would go first. So that's why we're going to get rid of them, or rid of it. And we get 2 here. And then we've learned our rules for logarithms. And if we log both sides, whatever we do to one side, we do to the other, we would be allowed to move the 52t to the front. And then it brings it down with the rest of the problem. So 52t, that just means multiply. That's why I don't need to put parentheses. Okay, so again, we're trying to solve for t. This whole time we want to get t by itself. That's why we wanted to bring the 52 down to 52t down, so that way we can now divide by 52 to get rid of that 52, and divide by log 1.001 to get rid of that. So then the t would be by itself. So we're going to divide by 52 log 1.001. So if the problem asked for the exact answer, this whole thing would be the exact answer. But if we told someone it would take this long, people would look at us and be like, what is that? Like, how many years is that? So we're going to put it in our calculator, and we're going to do log 2. You could click equal or divide, your choice. I'm going to click equal just so it computes that. And then divided by, and I need parentheses because there's 2 numbers. If you don't want to put parentheses, then you're going to have to divide by 52 and then divide by log 1.001 as 2 separate divisions. So if I want to enter it all together, I need parentheses. Log 1.001. I'm putting a parenthesis there to close that parenthesis, and now I need to put a parenthesis to close the whole denominator. So you'll know you did it correct if you get this same number. Now it says to round to the hundredths place, so that means 2 decimals, so I need to go to the 3rd place. And since this is 5 or higher, it's about 13.34 years. So a little bit less than 13.5 years it would take Sarah to double her money. So here's the steps all